Okay, let's dive in. Let's talk about authentication. I jumped around a bit there, but hopefully that was a bit of a warm up and refresher. Um, and there are some diagrams I think will be useful to see. I was playing around a little bit yesterday with a couple resources out there. Like there's this pretty great site, websequencediagrams.com, and I kind of wrote out a flow for get all students. And so I think for the Pokemon, it might be useful to like build these out as well. And I'll probably be getting you all some diagrams. And you can see here, you can add this pretty easily. And we'll see this, we'll come back to this a bit later once we have built out our authentication. So there's a couple things we're going to be doing here. We're going to learn something called token authentication. We'll talk a little bit about other methods, but we're going to focus on this one for a variety of reasons because it's useful and flexible. We're going to see how to use some of Django's batteries included features with something called the abstract user model for user accounts for passwords that then have authentication, and how to create those tokens. And then once we have created like these users, how to have them interact with our other models. And where we're going to be going with this, and this is also, I think, what we'll probably spend a part, if not all, of our review doing tomorrow, is adding user authentication to our to-do list. I know that the to-do list is a bigger project. So, you know, again, I want to know what people want to do for review, but this very well may be our focus for the review day tomorrow is a to-do list with authentication. So I'm just going to walk through some of these different approaches very briefly, and then we're going to kind of get to the good stuff, which is token authentication. And authentication, you know, the problem that we're solving here, and this bears mentioning, the problem that we're solving is I've got my server and I've got my client. And let's say here, you know, just browser and but what is also out there is, let's use a diamond. Once my Django API server is up on the internet, it's there for the whole world, right? And I've got these routes, API v1, you know, Pokemon, and API v1 moves, and API v1 noun. And I'll add some URLs just to kind of illustrate, like, let's say we have now put this on AWS and it's, you know, my site.com. Right, we've gone ahead, we've bought the domain name mysite.com. We've done our deployment lesson and deployed our Django server onto like a virtual server on AWS. We've deployed, we'll learn how to, we don't use vdev server. We will use Nginx or something, or we could even use Django, but we need to have a server and endpoint to serve up the React app, which is what vdev server does right now. I'll move this a bit out of the way here. And we have these endpoints, right? That we can then have our client interact with. And we've seen this and we've learned this. I can do like I just did a moment ago. I could do a post request, post API v1 Pokemon, and in the request body, I can put my info about my new Pokemon, name. And I know this is not proper JSON. I'm just kind of, I just want to get an example going here. And we'll put the browser all the way off over here and put our arrow over here. And just as an example, right? This is an HTTP post request. Now, we know that we've got validation logic on the server, and there's some validation logic on the client. But the rule with anything that's exposed to the public internet is you can never, ever, ever trust the data coming in. Because it's not just my React app that can talk to our Django server once we are deployed. It is also anyone who wants to be malicious or simply is learning and maybe makes a mistake, and maybe they're sending a post request too, and it's like post, excuse me, sure why I did it that way. Post API v1 Pokemon. But maybe they're in the body of their request, it looks something like this: name, like something like semicolon, drop all tables. There's a comic online somewhere about this. And this is called SQL injection, where when we try to stick this in our database, this semicolon gets read by Postgres and it ends whatever SQL is happening and then executes this next bit here, right? And actually, this is a bit of a classic. And it actually, I think they had to do it better here. I mean, you maybe need the closing parentheses. But this is your son's school. We're having computer problems. Did you really name your son Robert, single quote, close parentheses, semicolon, drop table students? And yes, the mom did, because she's a programmer on a mission, teaching people to sanitize their database inputs, where we need to make sure that we're not just like blindly putting the text that we're given into the database. And there are some things that we haven't looked at that can do this. And then a lot of the tools that we're using already do some of this already for us. Right? And maybe worse, even worse, this malicious Python script is making this post request 1,000 times a minute, which would be a DDoS attack, right, to overload the site. So we can put whatever validation we want on the front end. We can never, ever, ever trust that. We always need validation on our back end as well. And this is a little bit long-winded, but this is also why API keys come into play, because we have our REST API. Let's say we want to rate limit, we can rate limit by IP address. We want to be able to authenticate, and we need to really be able to control access. So this is the problem, right? And to kind of describe this problem a bit more, since HTTP is all about requests and responses, and all the data that our server has to make the decision is whatever data was in that HTTP request. We need to put all the information that the server needs to know if this person is authenticated or not really in that request. We'll talk about like cookies a bit later. But that's the real issue here. And without going into it too much, that's why HTTP is referred to as a stateless protocol. There's no persistent connection maintained between the browser and the server. It's all these little HTTP requests and responses going back and forth. So there's a bunch of different strategies for authentication. Basic authentication is the simplest. Every single HTTP request, we send a username and password. Right? So we might, like, literally with every post request, like here in our body, we might say, you know, as a request header, authorization, Adam, like my password. And now we can tell the difference between me and a malicious hacker. And in fact, there is an authorization request header, and we'll be using that later, because this malicious Python script hasn't created an account and doesn't have a username and a password. And in fact, I should just make this correct, and we'll put authorization basic. And this is literally what you see in the HTTP request header. This is baked into browsers and it's widely supported. We are passing our username and password in plain text. Most things use HTTP secure, HTTPS these days. So it is encrypted. So that actually makes it okay. So for simple use cases, it's okay, but we generally want to avoid this. This is not a good idea. There's a bunch of ways for this to go wrong. There's also something called session authentication, where what happens is Django can create what's called a session where I log in and my browser gets a session ID, and that's stored in a key on the client side. And without going into cookies too much, basically cookies are like the one thing that can sort of be passed along with HTTP requests. And you can actually go in DevTools. It's hiding somewhere in here. There it is, under storage, cookies. And I can see for github.com, I have all these little cookies. And a cookie is basically a key and a value. It's like a little tiny comma separated list. And we do URL decoded. There's not much interesting in there. And there's all these little things, preferred color mode. So this is actually for github.com, which is where I am right now, by the way. And that's why we're seeing it. And actually, if I navigate somewhere else, like let's go to wikipedia.org. We can see there's some cookies here for Wikipedia. And so what the browser does is it restricts cookies to specific websites. And when I go to a web page, my initial like loading request, it'll actually send any existing cookies in that request. Like if I go here to request cookies, I can see I'm sending all of these things. So the very first time I go somewhere, and I think this will work for this. Let's go to wikipedia.org. So if I kind of look at these network requests, I can see that the very first time an incognito window gets rid of caching and cookies, I go to Wikipedia. Wikipedia sends back these cookies, and the cookies, it's literally just like a little comma separated list of a key and a value. And we can't see it here, and we see it sort of nicely printed here. And it's used for stuff like location, some IP address, you know, other things here that we don't care about. And this is also how like websites know when you come back, right? When you don't have a user account and you go back and the website has remembered what you've done, it's because the website sent you a cookie. And what the browser does is every time I go to that website now, I will always be sending that cookie. So like I can go ahead and clear my network requests, and I can go ahead and I can type cats. And now we've got cats, and let me just find really any of these. You can see there's so much stuff that happens. But what's sent in my every request to Wikipedia now is some cookie information, and my browser has stored that. And so you can do, that is one way to do, say, a session. Basically, we stick like a session token when I log in a cookie that goes back and forth. There are some trade-offs to that as well, and some reasons we don't want to do that. But with the cookie, we still have to pass that session ID back and forth, right? Every request would need a little cookie with that session ID. And so, you know, we'd have like, and this is in fact happening all the time with websites. We are passing these cookies back and forth. And I don't remember why, but it's an interesting Google to see where the term cookie comes from. And the theme here is somehow I need to send some kind of special token or information on every HTTP request telling the server I'm authenticated. And we are going to do that with what's called token authentication, which is a little different. We create a unique token for each user when they log in. So we're going to see how to create user accounts. Django, we will save like probably a hash, basically save that token to the database. And every request we send needs the token. So the difference here is a token is not a password. It's generated every time I would log in, right? So if somehow the token, someone malicious captures the token, it's only good for so long. It's not a cookie, and the way that browsers handle cookies is a little different and slightly older. And using a request header that looks like this, this authorization header actually gives us a lot of flexibility. And if we have this in our request body, now we're authenticated. And now what happens in this scenario is, in this response, we get a 404, or it might even be like a 500 not authenticated response back, right? We are going to set up our API so that if you, unless you're logging in or creating an account, if you don't have an auth token, then you can't do anything. So that's a little bit of a preview of where we're going. I do want to get into writing some code, but I just want to pause and see if folks have any questions about stuff. Clarice, yes.
Is there another option? Like, I don't know about anyone else, but I get super annoyed with giving my email to each and every single app because it's nonstop emails for one, and it's just really annoying. Has anyone started to come up with like another option to authenticate users so they're not malicious, but you can still use the site?
That is a great question. Yes, but it's called single sign-on, and you've seen it when you can use your Google account to log in somewhere. There are other things than a Google account than one can use. There are certain other like trusted third-party sites. There's this third-party service Auth. But in essence, the user has to have an account somewhere, and then we could set up our server-side code to basically trust that. And actually, if someone wanted to implement like single sign-on with a Google account for the personal project, that would be really impressive, because it's very doable. It is a little bit of work because there's a lot of back and forth in the requests to get that initial handshake and authentication. But that is a great feature because that is a real problem and a real pain. There are a lot of other things we can do in terms of like rate limiting. But in essence, no, it's a hard problem, and it goes back to how do you know on the internet who's who. And there's this comic that I might have shared the other day. On the internet, no one knows you're a dog. And the joke is, well, maybe the dog is just talking to a bunch of other dogs on the internet. So if we need to be able to figure out which users, which IP addresses are trusted and which are not, we need to have some way of uniquely identifying them. And it very quickly becomes difficult to do that without connecting it to something real, like an email or something else. Which is it's a hard problem. The people have kind of been trying to figure that out, but in essence, no, there is not. We don't necessarily have to make our APIs require authentication for everything. There are those free APIs and stuff you saw, like, and we can add plenty of stuff like rate limiting. The other reason, though, that we do this is because there is stuff that a lot of the times we want with user accounts. Like, depending on what our app is doing, we might want people to make a user profile. But you might decide, hey, for my personal project, parts of my app don't need authentication at all. And those API endpoints don't need this authentication, this authorization token. But certainly if someone's going to have a user account and they can, like if I want to select save sites, then we might want authentication and an account for that as well. There is ways to store stuff on the browser with local storage. So I could like do saved sites and kind of have it saved in the browser, but it's not a great idea because the user could always like get rid of local storage. Basically, like the rule of thumb is like if we want the user to be able to like save stuff, we need to save that in a database on our end, and then we have to know who is what user. And trying to kind of identify just by IP addresses is too difficult. Yeah, that's a great question. I saw a couple other questions in the chat, and I'll touch on one or two things, and I will get to coding. Josh, authenticator apps like LastPass and stuff that you put on your phone are probably not using cookies, though I honestly don't know. They might do a variety of things. And it does start to get more complex the more secure you want to be. Yes, Sean, I actually was thinking of mentioning Sam Altman's thing, which I have really mixed feelings about, especially since this is not run by like a government. But the guy who, like, Sam Altman is this guy who helped found this startup accelerator Y Combinator that runs Hacker News. And most of all, as many of you might know, he's the head of OpenAI, in essence, or on the board. And this is like, he's sending out physical devices, and we're going to scan our eyes and get biometric data and go into this database so we can uniquely identify every human on the planet. And then we're just going to trust whoever's collecting all our bio data to be really, responsible with it. Anthony, what's up?
Hey, I just had a quick question about like the authentication. Like, even if you do have an authentication token, you could still do like some malicious stuff, right? Like, is that just different layers of security that you need, and like the authentication is like very base level?
Absolutely. Absolutely. Yeah, there's definitely like authentication doesn't mean that we can just trust user input, because our malicious programmer could sign up for an account as well. You're absolutely right. Yeah, security is all about layers. Like a good example of this, we're not going to get into too much detail, but what we're going to see in a little bit is we never store a password in plain text in a database. We use something called the hashing function that lets us, like, if my password is password, a hashing function will turn it into a bunch of numbers and letters, but do it consistently so that every time I send Django my password, I can run my hashing function. And, actually, I'll just type this out. Right? We might do, password equals password. We might run our little hashing function. Actually, let's just do it like this. And this might return, XYZ 1, 2, 3. And this is what gets stored in the database, the XYZ 1, 2, 3 bit.
So your password is not actually your password.
It is, because then what happens is when I log in, we would do something like hash, request.data.password. And let me move this over here so it's a little easier to see. And let's say, like login password. And I'll scooch over a bit. And this is actually a preview of what we're doing in a little bit. So this is actually good to see because we're going to implement this. And Django makes this really nice for us. And do something like, if, and really, I guess this should be called, this is now called like hashed password, right? And so this function, if I give it the same input, it hashes it the same way every time. So this is going to return XYZ 1, 2, 3 every time I put the string password into this function. And we store that hash in our database. And we say if hash password equals, like user dot hashed password. And then, this is user is authenticated. So we have this, the math is not actually that fancy, but we can't go into it now. So we have this way of taking the secret that we care about, a password, consistently turning it into something not secret. But the way the hashing function works, you can't like reverse it. It's much harder to go from XYZ 1, 2, 3 back to password for reasons that are a little out of scope right now. So I can put XYZ 1, 2, 3 into my database, and that's actually much safer because if some malicious hacker somehow gains database access, this way they don't just have tons of plain text passwords. And yeah, eventually they can probably turn the hash into a password, but it takes a lot more time and effort. And there are all these data breaches that happen. I think there was a Target data breach years ago. Let's see, data breach with plain text passwords. Here we go. Like you can just click and find all of these things of where companies are not being responsible with fundamental stuff, because there's not much more to this concept beyond what we're talking about right now. And yet time and time again, companies end up storing passwords in plain text in a database. And then if someone hacks or gets access, or it's just, we don't necessarily want all the other programmers to see all the users' passwords. Uber had a huge problem with that, where Uber engineers were like looking at where people were going when they shouldn't have been and stuff like that. So there's all sorts of reasons why we don't want to store plain text passwords in a database. And there was a question of if this gets into cybersecurity, and the answer is a little bit. It's a fuzzy line. Security gets like much deeper and specialized, but there is like a sort of baseline level of responsibility as software engineers that we have. And the good news is that like it really boils down to like just a few basic concepts. So web security fundamentals: never, ever blindly trust data that comes into our API from the outside world, right? i.e. an HTTP request. We always need to do this validation logic. Even if we don't have an authentication token, we might want rate limiting. If someone makes a mistake, we don't want that SQL injection attack where someone's name is, drop table students or something like that. And the good news is these days, Django does a lot of this for us. It's just important to be aware of this, and kind of know where the blind spots are for when maybe we do need to do a little more research. Never ever store passwords in plain text in a database. And be very careful with any other sensitive information going into a database. Right, and this one, let me make this a separate one. And let's just say be thoughtful, because this is much fuzzier, right? And there's so much sensitive information. Like if we're writing software for a bank accounts might be stored in plain text in the database. And banks, I'm sure, have to deal with the major issue of making sure their software engineers aren't messing with people's bank accounts. Like if you work at Google tracks every single thing its software engineers do. And that's not just for tracking and sort of, maybe less understandable reasons, but for really valid security reasons as well. And there's a lot of trust. Like at the startups I was at, I had access to the production databases with a lot of information, and it was all backed up somewhere. So if I, decided to do something bad, like the data would still be there, but we will have a lot of access as software engineers. So it's good to just start thinking about this stuff. I do want to, we should take a break and start writing some code, but I do want to see if folks have any other questions about this stuff, because this is a good conversation to have. Oh, there is one more rule actually, and this should be really rule 0. Never ever write your own encryption algorithms, etc. Use highly trusted third-party libraries whose code has been reviewed and vetted. Encryption and stuff like that, it starts off simple, and then very quickly it turns out that, like with all of the stuff we've seen in programming, it's simple until you make one really easy mistake to make. And then all of a sudden, a hashing function isn't actually doing what it should, and it's like stuff isn't encrypted right. So we always want to we don't want to reinvent the wheel. We're lucky to live in an age where there's a lot of really good third-party resources out there to encrypt and do all of that. And the devil's in the details with this stuff. So these days, the best way to write a secure application is to use the tools that other people have written, and Django does a whole lot of that for us, which is great. And do folks have any other questions before we break? Okay, cool. So there's a couple pieces to this, right? But the cool part of what we're going to do with token authentication is it'll let us create user accounts, and then our users can do more stuff. There's a lot of value to this. Like the to-do list is the perfect example. Like we can implement a to-do list with like cookies or local storage and things like that. But really, if I'm a user and I'm making a to-do list, at that point, I kind of want an account because you kind of want it for that feature set. And if people are interested, it would be great to use things like local storage for your personal project. Like when I go to Excalidraw, I think I might have eventually made an account there. But a lot of these sites like this, they do save your stuff, and that's using the browser's local storage most likely, and we can see how to implement that as well. Though that's a little outside the scope and would be more of an optional thing, but that would be an awesome feature to add for a personal project. So let's take a break. And what we're going to see is that Django has a class for us named abstract user. And it does pretty much all the work of authentication. Like there's some configuration stuff here, but just to jump ahead a little bit and give you all a preview, this is our sign up API view. It's not a lot of code. We're hooking into things that Django REST framework, and I'll make this a bit bigger, that Django REST framework and everyone can see my screen, correct? With awesome. That would have been bad if we had gone like an hour. We're hooking into these things that Django REST framework and Django gives us that do all of this work, which is honestly really, really great. And then the login API view is not much more, right? Where kind of like we were talking about hashing, we're going to get the email and password from the request. We're going to use this built-in function from Django, Authenticate. That's going to kind of do the hashing and the checking of the database for us. And then we can create an auth token and send it back. It gets the tricky bit actually ends up being on the client side, which is we'll get into a bit later. But the main thing that we have to do, and this we actually will use the browser's local storage for this, because we do need to hold on to that token once we get it from the server, and we need to send it with every HTTP request. But the good news is this is such a common thing that Axios has a helper here for us. So you can see like what we're doing in our happy path, like what we do once our Axios request succeeds and we make a post to register and we get back a token from Django, is we're going to put it in the browser's local storage, which we haven't talked a lot about, but basically the browser has its own little memory and it stays there for, I believe it's like the session. I think if you quit the browser and reopen, that's when it gets wiped. Excuse me, that is session storage. Local storage, I believe, lasts longer, and you can quit the browser and come back and the token's still there, which is why tokens have an expiration date kind of built into them. But more so, we're going to see Axios lets us in one line say, for every single HTTP request I make with you, Axios, add a header, a request header named authentication, and put this token in it. And that's how we're going to authenticate. So the front end implementation is a little trickier But even there, these tools do a lot of the work for us. Really, it's our job is kind of understanding the flows that happen here. And I have a couple diagrams that I'll get into later to look at that as well. But let's take a break and let's take 10, and then we'll dive into writing this code. Now that I think we've kind of done a good walkthrough of some of the important concepts, let's go ahead and take 10, and then we'll write some code and see how to implement token authentication, which is going to be awesome. So thank you very much, everyone, and see you all in 10 minutes.
Hey, Adam.
Hey, what's up, Andrew?
Hey, just in case you didn't see my message, I am back.
Oh, thank you so much.
Yep.
Yeah, I remember you had something going on today as well.
Yep. Just had an interview. So
That's awesome.
I'll be here for the rest of the day though.
Perfect.
Thanks.